What's up, everybody? This is Ed for my Bring Back, and I'll have you know that I am a sucker for metaphors. And so I've got one for you right now, and that is that I have walked you to the edge of the pit. We've been spending time in the last several videos exploring concepts about class in Python. And if you look at other tutorials online in this language and the way they're structured, typically the next thing you address is called inheritance. But that's a confusing subject, if you will, a bottomless pit, and a pit into which I am not ready to jump. So rather than jumping into that pit, we are going to pull back and take a little bit of a look at where we've come from. And I know that sounds abstract. Turns out it stays abstract because we've reached the point where abstraction becomes wildly important. But instead of talking about it, let's take a look. So a question that a lot of people watching these videos might have is why? Why do I need to instantiate classes? Why do I need to take the time to define these things? Why can't I just do something as simple as instantiating the variables, writing the functions that I need, and retaining them separately from one another, instead of taking the time to learn all these new and sometimes confusing concepts? And those are legitimate and decent questions, and the answers to these questions are not simple, and they touch on some of the more, I don't want to say profound or contentious, but interesting portions of what keeps people coming back to computer science. And the answer is multifaceted, right? It's manifold, but I can only give you a simple version of it because that's kind of the level we're at here in these 4-minute videos, and I hope that's compelling to you. The answer is ultimately about intelligibility, right? When we make objects, those correspond to concepts that we can understand in the real world. When we create a class, when we spend the time to define a class, the attributes that it has, the methods that it's capable of doing, it matches up with the way we think about the world outside of the computer as well. And so that is the big advantage, at least the one that's easy to communicate in this forum at the level at which we're working, to object-oriented programming, is intelligibility and having a program structure that corresponds with the way we think about the rest of the world. So when we talk about classes and instances of classes, objects corresponding to notions that we have about the real world, I'm going to be a little bit more explicit about that and give you some examples. We could say that these are merely just collections of functions, and that's not quite the case because they contain data as well, attributes specific to that class and its instantiated objects. Collections of functions are called modules. We'll actually explore those pretty soon here and take a look at writing our own modules, putting them to use. But that's not what we're doing. We're doing object-oriented programming, or when we're looking at classes. So let's take this dog, for example. If we wanted the class dog, we wouldn't just have to capture that it jumps and swims. We'd also have to capture things like its color, its size, its shape. And this is how we can say classes correspond to our notion of things in the real world. They contain both data and functions, or methods, we'd say, that operate from within or upon the object. So that's a very, very brief look at why we're doing what we're doing when we're doing a look at classes in these videos. And I know that this is rather disappointingly shallow for those of you who understand these concepts better. I don't mean to obfuscate or confuse anything from anybody, but just want to give you a little bit of background. So this is Ed for my Bring Back. Appreciate you sitting through a relatively abstract and perhaps uninteresting video. We'll get back into the Python code right away next up here. Just wanted to let you know where we were at and why we're doing what we're doing.